just in case you didn't realize this, when I say, ooh, I like this problem, it's probably going to show up on some graded thing. I love everything we've done today, to be honest, but this one especially. Y-intercept, where's that sucker?
9,000.
Yeah, so we call it the y-intercept because it's where it meets the y-axis. What is that exactly? What point is that?
0.
Whenever I ask you for an intercept, you better give me a point answer. Give me a number answer that don't make any damn sense. And I'm doing that to help you, believe it or not. What does it mean?
The starting point.
Be more specific about this particular problem.
How much you started with?
How much you, and what is this problem all about? It's the value of a computer over time. It's sort of like buying a car, and the minute you get into it, it's starting to depreciate. You know, you drive off the thing, and it's like, let me sell it back to you for $3,000 less. Oh shit! So you bought the computer for $9,000. See? So go totally into the actual physical situation. After 0 years, that's when you bought the damn thing. It cost $9,000. All right, now how do you find the slope? That's great. I could actually just use these 2 points here. They kind of want you to use these 2 points. Screw them. Let me just do this one. If I go down, how much?
2.
It's not 2. Be careful.
-2.
Look at the scale.
$800. Oh, no.
All right. Which 2 points? Oh, okay. I see. You guys are using like, maybe. I'm giving you some credit here. Are you using this point and this point? I was using this point and this point, but it doesn't matter. So yeah, if you go down 900, you go over 111. Don't say like steps, 1 step, 2 steps. You better bring in how big each freaking step is. So it's 900 per 1. 900 what? $900 per year. What does that mean?
Going down.
Yeah, you're depreciating in value $900 a year.
Would you write that as a negative 9?
Yes, I love it. So depreciate in value $900 each year. Yes.
So I used the points that they gave us.
Yeah.
And I got negative $3,600 for 4 years. So I just keep reducing that and just balance it out. Right?
Yeah, 3,600 over 4.
Yeah.
And when you divide 36 by 4, you get 9, so 900. Yeah, negative 900. Beautiful. So if you take a bigger step size, it will reduce to the same answer. That's the great thing about slope. Of straight lines. What is a right another answer like that? Yeah, something like this. Tell me physically what it means, right? And that's what
Along with the slope too.
Yes, so find the slope, bam. Interpret the slope, bam. I like it. That's the Emeril Lagasse way of teaching that. I don't know if you guys know Emeril Lagasse. Blah, blah, blah. Oh, here it is. Just a little bit more, guys. You alright? Yes, sir? So what's true here? In order to graph a line, you need at least
2 points.
2 points. Some of you guys now, in the homework I noticed, I warned you about this with intercepts. Some of you guys are finding like the x-intercept is 4, the y-intercept is 3, so then you plot the point 4, 3. And then you just kind of put a line through. Holy shit, no. You need at least 2 points, otherwise how do you know how it's going through that point? You have no idea unless you have another point. Right? Plus, if you find an x-intercept of 4, what do you really mean? The x-intercept is 4 comma 0. And the y-intercept in that example would have been 0 comma 3. They are their own points. Just plot one point and then put a line through it. No. Stay with me. This one, we did this example earlier. What's special about the point they gave me? Anything special about it?
0.
Which means it's the y-intercept. Yeah. So how do I plot this? So where's 0, negative 2? And then how do I move? The slope is 3 over 1. I always get somebody who just goes straight up 3 and then makes this up and down line. It's not 3 over 0, it's 3 over 1. So I go up 3, 1 over. I like it. Gosh, scheiße. They're really big. That's a big info. Now, they kind of throw this at you, and I know you guys have all seen this. Right? Have you guys all seen this?
Yes.
Yes. But now watch this. The reason this is the way it is, the B makes complete sense. How do you always find the y-intercept? Always.
0, put 0.
Put 0 in for x. So to find an intercept, you put 0 in for the other letters. So if I put a 0 in for x, what do I get for y? That's why this, whatever number that is always going to be in the y-intercept. Because it's what you're going to get when you put a 0 in for x. That's crazy. So if it's in this form, I can see the y-intercept. Now this little dude, the m, the slope, why does the slope go here? Because however much x changes, y will change m times that much. Isn't that what slope is? If I change by this much, the y changes by so much. Right? So if my slope was 3, I change by 1, I go up 3. 3 times as much. So there would be a 3 here if the slope was 3, because that's what I call the amplifier. It amplifies how much x changes to see how much y changes. Maybe. Okay. So this guy, so if I had, for example, y equals negative 2x plus 11, can you tell me anything about that line? Be more specific. Y-intercept would be what? No. You're not completely wrong, you're just a little wrong. The y-intercept's not 11. 0, 11. I know, that seems like, Jeff, what the hell? Are you getting us back for your teacher being so freaking... No. The y-intercept is a point. A point needs 2 parts, period. End of story. Y-intercept 0, 11. What's the slope? Yeah. Negative 2 over 1, 11. So if I have it in this form, I know 2 things about it. The most important 2 things. Where does it start and how does it move from there? Kicks a lot of ass. So that's the phrase for the day. It's fair enough. So for example, this dude, page 31. What's the slope? Again, negative 1/2. Which means what?
It's a decreasing 0.
Okay, good. You can say down 1. I like it. It's going down. You're right. It's decreasing. Down 1 over 2. Not back 2, right? There's only one negative. If you put it on top, it can't also be on the bottom. What's the y-intercept?
0.
There you go. I was going to keep going until somebody said it right. So you start at a point on the line, and then you follow what the hell you just said to do. You start at 0, 3, and then I go down 1 over 2. Now here's what's really cool. Now that we've connected it to an equation, here's what kicks, again, insert the phrase today. It just does. I don't know how else to say that. What's got to be true about this point? What's got to be true about that relative to this?
You can fit in that equation.
It's got to work in the equation. A line, I don't know if I've said this yet. You guys are getting really antsy already. A line is a visual representation of all the answers to an equation. Let's say that again. Maybe I haven't said that yet. A line, or any graph, is a visual representation of all the answers to any equation. So that is the most fundamental reason why we graph lines. So if I said, now watch, you guys can do this without much work. Can somebody give me one answer to this? X plus y equals 9. Yeah, 8, 1. 1, 8. What else?
6, 3,
6, 3.
4, 5.
4, 5. I love it. He's bored already. 100, negative 91. So what about 1.7? 7.3, right? So how many answers are there to this? Infinitely many. So if I said, give me all the answers to this, you're just going to graph the damn thing. Instead of start to list. You'll be listing for the rest of your life, and the rest of your kids' lives, and you have to have them take over, and the grandkids. It's fun. All right. Right, but I'd rather just graph it, and then just say, go find whatever answer you want. I'm done with that shit. Next. You guys with me? I want you to understand, that's not the only reason. Nowhere near the only reason we graph things. But the most fundamental reason we graph anything is it's the quickest way to answer what's the answers. Maybe. So, that, what point is this?
2, 2.
2, 2. So how do I check what I've done?
Put it in the equation.
If I put 2, 2 in, negative 1/2 times 2 plus 3. What's negative 1/2 times 2? Negative 1. What's negative 1 plus 3? 2. So when I put a 2 in, I got a 2 out. So the point 2, 2 works. So on these kind of problems, you can actually check your work. It's always nice.
Kicks ass.
Thanks. All right. Feel like maybe. Let's see. What time is it?